Since the dawn of man, we have always dreamed of flight. Man has always asked himself this simple question: how too can I be up there? This age-old obsession with flight has carried on throughout the years, and recently has caught on with our team, who henceforth decided to enter this competition. When beginning the design process, our first decision was to make the plane body out of 3D printed parts. This was due to a multitude of reasons. Firstly, 3D printing the plane body allows us to replace parts with relative ease, and this really came into handy during the testing process. Secondly, this allowed us to customize our airplane's characteristics by getting really accurately reproduced parts such as the aerofoil and the body shape. Lastly, lightweight PLA could be used to 3D print out a foam-like material, allowing us to have all the benefits of 3D printing whilst still having the benefits of more traditional materials. Of course, we didn't decide on our current design immediately. We ran through many ideas and took the challenge requirements into consideration before finally choosing our current design.
In order to achieve good control over the plane, we needed the plane to be stable. This was done by firstly using a flight controller with an inertial measurement unit that can detect unintended deviations in the plane motion, and then proceed to correct these variations automatically. We also added some wing dihedral for increased roll stability, as rolling to one side will generate more lift on that side, thus countering the roll. However, we did not give the wing too much dihedral as it can affect the maneuverability of the plane, and the flight controller already served to counter the instabilities of the plane. Thus, our aircraft wings are moderately angled upwards.
Our wing has a moderate aspect ratio. This is to balance the positives and negatives. High aspect ratio wings have low drag at low speed, but low aspect ratio wings allow our plane to be more maneuverable due to the lower moments of inertia and require less support due to a lower bending moment. The extra space due to our aircraft's size was utilized to house 4 control surfaces, namely a rudder, elevator, and 2 ailerons. They were made to be as big as possible to allow reliable and accurate control of the aircraft to allow us to more efficiently navigate the obstacle course. The servo used to control these control surfaces are small 9-gram servos, as they are strong enough for our target speed yet decently lightweight. The drawing were then digitized and used as a reference for the final 3D model in Fusion 360, allowing for testing and 3D printing of the plane.
As our aircraft will be fully 3D printed, the material weight can be very accurately calculated from the 3D model. We then made changes to the design of the aircraft to keep it under the 250 grams limit of the competition. Using the 3D model also allowed us to determine the center of gravity, or CG, of the plane in software. The components of the plane include the servos, flight controllers, and battery, and then can be shifted around inside the plane such that the CG of the plane is in line with the center of lift of the plane, giving us good, easy, and effective control of the plane using the control surfaces. We then printed all the components of the plane body. We assembled the plane using glue to attach the different components of the plane body together, and tape to attach control surfaces. A few iterations of the aircraft was 3D printed and constructed, as several small details had to be updated in the design to allow for the best final product, highlighting the benefits of using 3D printing.
We then wired everything up and programmed the flight controller to understand the layout of the plane. Our plane crashed many times throughout the testing and suffered considerable damage, but the replacement plane parts were easily 3D printed. During testing, we encountered a problem with the design, which was the landing gear. Our original design was a tail dragger design, but this caused the plane to become very unstable in the yaw axis when accelerating for a rolling takeoff. We then switched to a tail wheel design, which allowed us to have more reliable and much straighter takeoffs. Our plane is a testament of how the most cutting-edge technology, such as 3D printing, can be used to create something which could not have ever been dreamed of not 50 years ago. A key takeaway from this project will be the concept of rapid prototyping using 3D printing. We are now one step closer to connecting with the heavens, once again showing off the spirit of human ingenuity and our will to never give